So again, this lesson focuses on solving systems of equations using substitution. With these equations, if you have a variable that's equal, or your equation that's equal to a variable, you can actually take the expression and plug it in for that variable into the other expression or the other equation, and then you just solve. Sometimes you will not have that, and you're going to pick one of the equations to work with, preferably the one that has a coefficient on one of the variables as 1. Solve the equation for that variable, and then plug in what the expression is for that variable into the other equation and solve for the other. From here, or if we look at example 1, we have y is equal to 6x minus 11, and negative 2x minus 3y is equal to negative 7. For this one, you are going to take that 6x plus 11 and plug it in for y in the other equation. So we have negative 2x minus 3 times 6x minus 11 is equal to negative 7. We're going to distribute the negative 3. This gives us negative 2x minus 18x plus 33 is equal to negative 7. Combine your like terms from here. So this gives us negative 20x plus 33 is equal to negative 7. We're going to subtract we're going to subtract 33 from each side. So we have negative 20x is equal to negative 40. From here, divide each side by the negative 20. This gives us an x of 2. Now that we have for x, plug it in for that y is equal to 6x minus 11. So this is going to give us y is equal to 6 times 2 minus 11. The 6 times 2 gives us 12. Minus 11 is 1. So we make an ordered pair out of this x and this y of 2, 1, and that is our solution. With these, if you want to check your solution, you can substitute in the x and the y for either one of those equations, if not both, and you should get true statements for both of them. The next one we're going to look at is number 4. We have negative 3x minus 3y is equal to 3, and y is equal to negative 5x minus 17. You have a y is equal to here, so take this and plug it in for y in the other equation. This is going to give us negative 3x minus 3 times negative 5x minus 17 is equal to 3. We're going to distribute this negative 3 into the set of parentheses. So we have negative 3x plus 15x, the negative 3 times negative 17 is a positive 51, is equal to 3. From here, we're going to combine those like terms. So this gives us 12x plus 51 is equal to 3. We're going to subtract that 51 from each side. So we have 12x is equal to negative 48. From here, we're going to divide each side by the 12. And we get that x is equal to negative 4. We know that y is equal to negative 5x minus 17. So plug in that negative 4 for x in that equation and solve for y. So it's negative 5 times negative 4 minus 17. The negative 5 times negative 4 gives us 20. Minus 17 is 3. So our solution for this one is just negative 4, 3. The next one we're going to be looking at is number 5. We're given y is equal to negative 2 and 4x minus 3y is equal to 18. If y is equal to negative 2, we're going to plug it in for y in that 4x minus 3y, which is negative 2, is equal to 18. This is going to give us 4x plus 6 is equal to 18. We subtract the 6 from each side. We get 4x is equal to 12. Divide each side by the 4, and x is 3. We know that y is negative 2, so to make an ordered pair out of this, it just gives us 3, negative 2. The next one we're going to look at is number 11. We have x plus 3y is equal to 1, and negative 3x minus 3y is equal to negative 15. We first are going to look at this first equation. We have x plus 3y is equal to 1. We're going to solve this for x since neither of those equations are equal to a variable. So we're going to subtract the 3y from each side. We get x is equal to negative 3y plus 1. We're now going to take this negative 3y plus 1 and plug it in for x, and that negative 3x minus 3y is equal to negative 15. So this is going to give us negative 3 times negative 3y plus 1 minus 3y is equal to negative 15. Distribute the negative 3 in. This gives us 9y minus 3 minus 3y is equal to negative 15. Combine your like terms. This is 6y minus 3 is equal to negative 15. Move the 3 over, add it to both sides. We have 6y is equal to negative 12. Divide each side by the 6. We have y is equal to negative 2. Take that y is equal to negative 2, plug it in for y in the x is equal to negative 3y plus 1. So this is going to give us x is equal to negative 3 times negative 2 plus 1. Negative 3 times negative 2 is 6 plus 1 gives us an x of 7. So our order pairs x comma y, so that's 7, negative 2. Next, we're going to look at number 16. We're given 2x plus y is equal to 20, and 6x minus 5y is equal to 12. So because we have a y with a coefficient of 1 in that top equation, I'm going to take the 2x plus y is equal to 20, and I'm going to solve the equation for y. So I'm just going to subtract 2x from each side. We get y is equal to negative 2x plus 20. We then take that negative 2x plus 20 and plug it in for y in your second equation. So it's going to be 6x minus 5 times negative 2x plus 20 is equal to 12. Distribute the negative 5, so it's 6x plus 10x minus 100 is equal to 12. Combine your like terms, it gives you 16x minus 100 is equal to 12. Add that 100 to both sides. We get 16x is equal to 112. From here, you're going to divide each side by that 16, and you get that x is equal to 7. Take the 7, plug it in for x, and y is equal to negative 2x plus 20. This gives us y is equal to negative 2 times 7 plus 20. Negative 2 times 7 is negative 14, plus 20 gives us 6. So our solution to this is just 7, 6. For the last one that we're going to look at number 19. We have negative 5x minus 8y is equal to 17, and 2x minus 7y is equal to 17. We want to take one of these equations and solve for the variable. It doesn't matter exactly which equation you use. I'm going to use the bottom one and just solve for x. So I'm going to take the 2x minus 7y minus 17, is equal to negative 17. And I'm going to solve it for x. So I'm going to add the 7y to both sides. I get 2x is equal to 7y minus 17. And then I divide each side by the 2. So I get that x is equal to 7 halves y minus 17 over 2. So I'm going to take that expression and I'm going to plug it in for x in my top equation. So I'm going to have negative 5 times 7 over 2y minus 17 over 2 minus 8y is equal to 17. I'm going to distribute the 5 or the negative 5 in. So it's going to give us a negative 35 over 2y minus 17 times negative 5 is a positive 85 over 2 minus 8y is equal to 17. That 8y is the same thing as saying negative 16 over 2 So I'm going to combine my like terms here of that negative 35 and that negative 16 over 2. So it's going to give us a negative 51 over 2y plus 85 over 2 is equal to 17, which is 34 over 2. I'm going to subtract 85 over 2 from each side. These cancel. We have negative 51 over 2y is equal to 34 minus 85 is negative 51 over 2. If we divide or multiply by the reciprocal, I'm multiplying each side by negative 2 over 51. These are reciprocals of one another, so they are equal to 1. So y is 1. To solve for x, we can take that 1 and plug it in for one of the equations, or into that x is equal to 7 over 2y minus 12 over 7, or 17 over 2. I don't want to work with that one, so I'm just going to use the 2x minus 7y is equal to negative 17 and plug in the 1 for y there. So we have 2x minus 7 is equal to negative 17. We're going to add the 7 to both sides. We get 2x is equal to negative 10. We divide each side by the 2, and we get that x is equal to negative 5. So we form our ordered pair of negative 5, 1, and that is our solution. You need to be mindful when you are doing these. If you get something that gives you a false statement, so let's say you get something like 3 is equal to 0 for any of this, you'd automatically have no solution. If you get something that's a true statement, so like 7 is equal to 7, it would be infinitely many solutions. So again, just be mindful of that and keep that in mind while you are doing these.